Today we're going to be multiplying um, binomials, or we are going to be expanding and simplifying quadratics. Okay, so yeah, so there might be some simple ones at first that are just binomials, but then there will be some trinomials that do appear, or just quadratic x squared type expressions. Okay. All right. So to start off with, start simple here. So I'm going to show you two different methods. I want you to get comfortable with both. Okay. But then in the end, it is up to you which way you would like to show your work. But yes, just keep an open mind for both methods, even if one you're like, it's not my thing. It might be helpful later on when we're trying to do something else with these quadratics, and maybe, right now when we're multiplying them and expanding them, maybe the area model is not your thing, but later on when you're trying to factor them, go backwards from what we're doing today, you might find that the area model is very useful. Okay, all right. So what I'll do is I'll kind of do one with the one method and do one with the other method, and then just go down the page here. So here's the first one. We want to multiply, okay, or expand and simplify. Those are the other instructions that you'll see a lot. Expand and simplify. Okay, collect any like terms up. So expand usually means like multiply the number outside into the brackets so that we can dump the brackets. And then if there are any like terms, you can collect those up. All right, so we'll start with the first one here. We're going to multiply. Here, let's give myself more space here. Okay, so we're going to multiply that 2 into the brackets. So we're going to multiply it here, and we're going to multiply it to the second term as well. Okay, so 2 times 3 is 6. 2 has not, like 2 is not, the number outside is not bringing an x in, so the x has nothing to multiply with. So just leave it x. The next one is 2 times positive 1, so it becomes positive 2. A lot of people will write just that, but you need to always write a plus or minus between these expressions, right, in these algebraic expressions. So you need to write plus or minus between these terms. So in this case here, 2 times positive 1 is positive 2, so write plus 2, like that. Okay, so if we are going to use the area model for the same question here, what you're going to do here is you're going to put this part that's outside the bracket along one side of the squares, and this other part here along the other side. Okay, so if you decided to make one that went this way, that would be okay. You could put 3x here and then plus 1 here. Okay, so that way one side of the expression is here and the other side's here. Okay, it doesn't matter which way. So since 2 is by itself, it'll be the smaller side, where 3x and plus 1 will need its own squares to match up. Okay, all right, so I'm just going to put the number out in front here, and then the number inside the bracket up here. Okay, so 3x and 1 have its own boxes. All right, so this area model method is just saying, hey, take the numbers outside the box and multiply in. So 3 times 2 is 6x, and then 2 times 1 is 2. Okay, so again, why is this area model method good? It reminds you how many calculations you should be making. I find with this distributive property method, a lot of people forget to do the second calculation, the red arrow here. They'll multiply the first one, and then I get a lot of answers like this, right? And you didn't even multiply the 1. Okay, so it's just to remind you, hey, there's 2 calculations to make here. All right, so with this area model method, though, you do need to take one more step here. I need you to write it outside of the box so you can clearly tell me that it's 6x plus 2, okay, not 6x2, 6x plus 2. And that's what this expands and simplifies to. All right, let's go to the next one, 3x times x plus 2. So again, we're going to multiply this into the bracket here. Okay, so 3 times, see how there's no number there? It's like a 1. Okay, so it's just 3 times 1 is 3. Okay, now we have a letter that we have to multiply in, and then this is the most common calculation with letters you'll do today, x times x squared. Okay, so you're wondering how did that happen? Well, back earlier years, you would have learned both these have an exponent 1, and so that means you can add the exponents to get to x squared. Okay, so x times x is x squared. So in this case here, 3 times 1, 3 times no number there is just a 1 there, it's not written, is 3, and x times x is x squared. Okay, all right, and then again, don't forget to do the second calculation. You don't need to write these arrows, but it just, remind yourself somehow to make, multiply, distribute that number outside throughout the whole bracket. So this time here, 3 times positive 2 is positive 6, okay? X times, this one doesn't have an x, so just x, like that. All right, and then, just like above and here, always check to see if you can simplify. Can I add 6x plus 2 together? No, they're not like terms. Leave it. Can I add 3x squared plus 6x? No, leave it, okay? All right, here's the area model. Same thing, I wrote the term on the outside over here, and x plus 2 here, okay? So we're multiplying in. So remember, when there's no number there, it's like there's a 1 there, right? So 3 times 1 is 3, and x times x is x squared. 3 times 2 is 6. X times no letter, just x. All right? Get them out of the boxes here. And there we go. There's your expression. They are not like terms. Do not add them together. Okay, so that's kind of more the just warm up. Okay, so just having one, it's called a monomial. It's just one term outside being multiplied into the binomial, which has 2 terms. So now I'm going to get you to multiply a binomial. There's 2 terms outside, and with another binomial in the second bracket. Okay. All right. So they like to call this method FOIL. It's still distributing kind of what's on the outside in, but they like to call it FOIL when it's like a binomial times binomial. And the reason why, so I'll write up here, FOIL represents first, you're going to calculate the first 2 terms together, outer, the outer terms together next, inner, and last. The last 2 terms together. Okay, so here we go. I can do it on this one here. So the first FOIL, okay, first 2 terms together. There we go. So again, remind yourself, when there's no number there, there's a 1 there. Okay, if you want, write it in. 1 times 2 is 2. X times x is x squared. All right, next one. X. So you're taking that first term, 1x, and you're multiplying. So because it's FOIL is first, now we're doing the outer terms. Okay, so see how these are the outer ones? Okay, I did the first of the 2 brackets. Now I'm doing the outer ones of both of the brackets. Okay, so that's 1x times 3. 1x times 3, that becomes 3x. Okay, FOIL says inner now, inner. So we're going to take the 2 inside terms and multiply them together. So 2 times 2x is 4x. And then we're doing the last, FOIL says last now, the last 2 terms of both the brackets. 2 times 3 is positive 6. Like that. Don't forget to write plus or minus in between. So if it's negative, the answer is negative, write negative 6 or negative 5. Okay, all right, so now we've expanded it. So the nice thing about this whole distributive property foiling area model, it gets rid of the brackets. Okay, the brackets are gone now. So now we can actually collect up any like terms that we might have. Okay, so 2x squared is its own term. Okay, but 3x and 4x are like terms. Okay, and then 6, it's its own term. All right, so the ones that are on their own, just write again. But then the ones that are like terms, add them up, subtract them, whatever they need here. So here we have a positive 3 and a positive 4 makes positive 7. X, okay, don't forget the x. And again, right now, just because you added those 2 together, it doesn't mean you're going to do what you did here, where you multiplied the x's and got x squared. No, when you're adding and subtracting, you're just doing this collecting like terms thing. So you're just finding how many x's there are. And then we're not changing the exponent. We're not making it x squared like that all of a sudden, okay? We're just keeping it x. So that's 7x and then plus 6. All right. And another reason why I want you to learn both of these methods is that maybe you did the FOIL, right? And then you want to check, did I do that right? Did I do that right? So you want to have a backup plan here and be able to use this the area model method as well. So here I'm going to I'm going to write the first one here, x plus 2. If you want to write plus 2, you can, okay? And then 2x and then plus 3. Okay, you don't have to write the plus, but if you want to, then that way, just, remind yourself it's positive or negative, okay? All right, so see how now, with FOIL, it told you first, outer, inner, last. 4 calculations need to be completed, right? So here with the area model, so a lot of people will kind of forget one of these calculations. They might do 3 of them, 3 out of the 4, right? So the area model kind of forces you to go, hey, there's 4 calculations here, write something in each of the boxes in it. So that's why it's a good method. Some people just don't like it because you got to draw the box. It takes a bit more time maybe. All right, so, but if you do like it, use it, okay? So 2 times, remember that's like a 1 here, right? If there is a 1 there. 2 x squared when you multiply those. Okay, now 1x times 3 is 3x. 2 times 2, so remember you're multiplying in, okay? 4x. And then the last one, 2 times 3 goes in here, okay? So now we got to get them out of the box. Okay, so you can write them all out like that. Some people like to just go, oh, these two are like terms. Okay, so right away, they just write all the terms and they add the like terms. So like, oh, I can add those two, 7x, like that, okay? Plus 6. So if you want to write them all out and then add them after, that's fine. Or as you're taking them out of the box, you can add them together, right? Those two are like terms. Okay, and then when you get to that final answer there, check to see, can you collect anything else up? Nope, they're all different. They're not the same. One has an x squared, one has x, one has no x, right? They're different terms, so don't add them. All right, and then you can check with the other method. Oh yeah, I got the same answer, so you know you're doing them correctly. Okay, all right, so just go through, maybe do D and E, and then start the video again. Okay, so I went ahead and completed these ones here. So this side FOIL, or distributed property, this side the area model. So again, remember how I wrote the positive 2 plus 2 and plus 3 here, but I said, you didn't need to. But here when it's negative, definitely put it on there. Make sure it's there to remind yourself you're multiplying with a negative number. Okay, so the 2x times x is 2x squared, positive, right? But then this 2 times negative 3 makes it negative 6, right? Negative 1 times x is negative 1x. Negative times negative makes positive 3. Okay, so just be careful with those positive, negative integer operations, okay? All right, and here x minus 1, x plus 1. You would have noticed when you're multiplying in with a FOIL or area model method that you're getting a positive 1 and a negative 1. So positive plus 1x and a negative 1x. See how these are opposites? So they end up becoming 0, right? So they're on opposite teams, so they bite 0. So they cancel out, right? And then you're left with the first term and the fourth term here. All right, so what happens when you see ones like this? Okay, so I want you to, with both methods, understand that it's actually just, they're squared, right? So, when something's squared, like 2 squared, it's the same as writing it like this. 2 times 2 makes 4, right? So that's what you would normally do when something's squared. So same with binomials. If they're squared, you can write them twice, like that. And that's the question that you're actually trying to work with here. You're trying to multiply the binomial with itself, okay? All right, so if we're going to use FOIL here, first, x times x outer, 2x inner, 2 times x is 2x, and then last, 2 times 2, 4. Okay, add up the like terms. The ones in the middle, and there, okay? So again, if it's helpful, highlight them, remind yourself, oh yeah, those two are like terms. These ones are not like terms. These are different, okay? So you just write them again. All right, if we're going to use the area model method here, okay, so again, multiply in. It reminds you to do 4 calculations, but then take them out of the box. Don't leave that as your final answer. Okay, if you can add coming out of the box, do so. If not, write it all out and then add up the like terms. All right. Okay, and then do the same with the next one. And yeah, and then we're just going to move on to what happens when there's a number out in front. Okay, so here is this calculation as well. Again, the key to success with these is that you want to just do lots of them, right? Because I think it's probably maybe straightforward to you now after seeing a few examples, but it might be that your calculation is too slow, right? Just you're multiplying and and then when to collect the like terms and so forth. So that's why I just keep practicing lots of these just to get your speed up and improve your confidence with calculations as well. Okay. All right. So this one here, yeah, just watch out for those positives and negatives, and then clean up the um, clean up the like terms. So just a reminder, remember, when you are collecting the like terms, you're just adding or subtracting the coefficients, right? You're not changing the x. See, it's still x, right? So just remind yourself of that. All right, so now what happens when you have another number out front? So it just means that it's another calculation, right? So what I want you to do here is I want you to calculate out these first and then leave the 5 until later, okay? Some people will multiply the 5 in. That's okay. You can do that as well. So really, it's up to you. But I find that sometimes when there's a negative and it gets a little messy when there's an x and other things. So in general, just multiply these and then multiply the 5 in, okay? But really, it's up to you, I guess, in the end. So just be careful, okay, when it's a negative. Yeah, so like if you were multiplying the negative, once you get your two numbers, keep them in the bracket so then you know which one's first, outer, in, or last, okay? Okay, so let's start with this one here. We're going to keep the 5 out there, and the key here is like, don't forget about it. That's another thing too. Don't forget about that 5. Okay, so I'm just going to really emphasize here that I am just calculating all the stuff inside the red bracket first, okay, and keeping it in the red bracket so that 5 stays out. Okay, so yeah, I added an extra bracket, okay, but it's okay. It's just remind yourself, do the stuff in here, but the 5's still waiting outside to multiply in, okay? All right, so first, outer, inner, and last. There we go. Whoops, bracket. Okay, keep going, clean up the inside, collect up those like terms. 4x squared is its own term, but 6x and 6x will make 12x plus 9 bracket. Okay, all right, now that we've cleaned up multiply the binomials together, we have that 5 now that multiplies in. And what does it simply do? It just multiplies in. Okay, all right, so again, here to everybody, all 3 of them. Just don't have enough space to write all those arrows. Okay, so now let's do that. 5 times 4 is 20x squared. 5 times 12 is a negative 60x. 5 times 9 is positive 45. Now we're done. Okay? All right. Oops. So now I want you to try the area model method. So what I'm going to do here to help you along with this is add another maybe another square here too. Okay. All right, there. So we'll need a couple boxes for this one just because there's a couple calculations to do. Okay. So again, what we're going to do first is we're going to do this part first. Okay. So that is this calculation. This one times itself. Okay. And then we're going to do the 5. We're going to multiply the 5. Okay, once we finish the brackets, the binomial calculation there, we're going to multiply the 5. Okay, but the key here is we got to remember for both methods, don't forget the 5. Okay, all right, so here we go. We're just multiplying the binomials, 2x minus 3, 2x minus 3. Again, I'm using different colors to just kind of show you that those are on the outside, these are on the inside, and then these are, what you should be calculating out. It doesn't matter if they're different colors though. All right, 4x squared, 6x, 6x, positive 9. Okay, and again, same thing. If you want to put that plus 9 in, go for it. Okay, it's when it's negative, you definitely need to write that. Okay, so just pop these out here. There it is. Collect the like terms in the middle. All right, so nice and clean, all done. Those are not like terms, so don't add them together. Okay, so here's the problem with these, right? A lot of people forget the 5, and then you're like, oh, I'm done, okay? But no, this 5 is still there, okay? So it's really now, it's 5 times 4x squared minus 12x plus 9, okay? That's what you still have to do. So the reason why I drew another box here is to show you can, like, if you like this method, keep using it, okay? So the reason why it's not a 2 by 2 is like, before it was binomial times binomial, right? Here now it's a monomial times a trinomial. So that's why I need 3, it's a 3 by, like a 1 by 3 box. Because the 4x will go there. Oops, I'll use different colors. Don't need to, but makes the note a little neater. Okay, all right, so the 5 is going to multiply with the 4x squared, the negative 12x, and the positive 9, okay, to finish this off. Okay, so some of you might find that I didn't really like the box method, but today maybe you do, okay? It's okay to switch. All right, now your final answer. Pop it out of the box. This is your final answer. Okay, so there's a lot of work shown there, so that's why it's clear. Make sure, like at the end, at the bottom of your work, show your final answer, okay? Or even if you have to write final answer right there, okay? All right, and then you use the other method as well, so you can double check and go, oh yeah, I did do those correctly. Okay, all right, so with this one here, yeah, we just need to use a couple area model boxes in order to get hack our way through to the final answer. So do the same with the next ones. Again, I know you can multiply that negative 2 in right away, but it gets a little tricky because all these negatives appear and so forth. So it's almost like just kind of be on the safe side. Leave it out there. Do the binomials first, and then calculate the negative 2 in. Okay, so just try those out and then start the video again. Okay, here is the next one here. So we have the negative 2 outside. So if we're going to use the distributive property FOIL method, I just worked with taking care of the binomial times binomial multiplication first. So I put a red bracket to say, hey, do this first. Don't forget the negative 2, okay? So once I completed that, cleaned it up, I have the negative 2 to multiply in. So this is where it's really important that you're paying attention to your sign calculation, right? So if you have your negative with a positive, it should be negative, negative with negative, positive, negative with a positive, negative, okay? So you get that answer there. And then you have this backup method, the area model method. So again, we're going to take care of the binomials first using the area model. Get this out. And then just a reminder, yeah, you got to put it with the 2 again. So multiply the negative 2 in, use the area model again, and then we get the same answer for both methods. Okay, so this is where it's key, where maybe you want to learn both of them so you can try both of them if you have enough time on a test or an assessment so that you can double check that you're doing it correctly. Okay, all right, here's the last one, or before we try the trapezoid question, but here's the last one where it's even more wrapped up. You have a binomial calculation here. You also have like monomial, multiplying in. Okay, so 4n multiplying in, and so forth. Okay, what happened to my pen here? Okay, so yeah, so you're multiplying this in here. Okay, you're not going to multiply it over here as well. It's the 4n's not in front of those brackets. So just multiply it there, so you get 4n squared, negative 12n, okay? All right, and then these ones you're doing separately using your FOIL, right? So that, I just kept going here. So that's your first 15n, outer 10n, inner 3n, last 2. Okay, then the reason why I was highlighting all of them here is to show you where all the like terms are. The n squares are like terms. Okay, there's 19 of them. The n's are like terms. So there's some negatives and there's some positives. So you have a positive 13 versus negative 12. So these positive 1n. Okay, so again, if you put the 1 like that, that's fine. But we don't write it like that. We just write it n. And then the 2 was by itself. It was its own unique term. So here's your final answer. Let's use the area model method in order to see if this is, if we can match that answer up. Okay, so if you see here, I'm using a 1 by 2 to take care of the 4n and the n minus. So I'm taking care of this right now, the 4n and the n minus 3 calculation. Okay, and for this 2 by 2, I'm going to take care of the 5n plus 1 times the 3n plus 2 calculation here, okay? And then I'll put them all back together. All right, so 4n's out here, n minus 3 is here, calculate away. This one I'll do set up at the same time. This is 5n plus 1, 3n plus 2. Okay, let's calculate away. All right, so this becomes 4n squared. We're multiplying into the box, negative 12, n, don't forget. All right, so I'll take those out. Here they are so far. Okay, and then multiply into this box, 15n squared, 10n, 3n, and 2. Okay, all right, take these out of the box as well. Okay, you can see the 10n and 3n are like terms, so let's add those up. Forget the other, the square though. Okay, so then we get to here. Okay, so now what we're going to do is we're going to add up this part, that's the first part, and the second part, okay? Because yeah, we're adding these two together, okay, to get our final answer. So I'll write it all down here. So we have our 4n minus 12n, okay? And then see how 15n is positive, so that's why we always put a plus and minus between terms. Okay, because otherwise it'll look like this and you're wondering what are you supposed to do with that, right? So you want to make sure you show clearly that it is positive. Okay, so I added both of the strings together. All right, and then again, it's just adding up the like terms deal here. Okay, so I always highlight the sign on the left to say, hey, that's negative. This is positive. And then this one is by itself. Okay, all right, so add them up. So that becomes 19n squared, 12 versus 13. 13 wins, there's more positives, and plus 2. And there we go. We got the same answer as the other method, okay? All right, so that's why you just got to pick a method that is working well for you, okay? And eventually, if you're wondering, which one is better, it's not that it's better, like they both are awesome, okay? But if you want to, I feel like the one on the left will get you to the answer a little faster, but there's a lot of room for error then, right? Because you have to like be calculating and making sure you're making all the different calculations. And then if you forget one, that's where the problem rises, right? Where the area model method, it forces you to make all the calculations that you need, and then you get to the right answer. All right, so yeah, so just like get comfortable with one of them. Again, depending on where you're heading after this course, you definitely need speed for some courses, and then others you need more accuracy, right? So maybe just get good at both of them. So, all right, last one before we can head to some practice here. Trapezoid. Okay, so this is a four-sided shape, a quadrilateral. Its specific name is trapezoid because we have two sides that are parallel and the other two sides of the four-sided shape are not parallel, okay? All right, so we have a side B1, so from here to here. B2 is like the whole length like this, okay? Try a different color here. So B2 is this whole, it's the whole base here, okay? B1 is from here to here. And then the height, that's the other piece that we need, is from here to there, okay? So A1 and A2 are just kind of there, but we don't need them for our area calculation, okay? I don't know, I think other formulas that you may have seen are like a plus b equals h divided by 2. So the a plus b is just the b1 and b2, right? So anyway, so we'll use the one we have here. So area is height times b1 plus b2, okay? And then we're going to divide by 2, okay? You can always put it under as well, but let's kind of go like this. All right, so let's just substitute all of our known values in. So height is 4x. Okay, so we're subbing that in. b1 is x minus 2, and then plus b2, 3x plus 1. Okay, and then we're going to divide everything by 2. All right, so BEDMAS will say do the brackets first, okay? Then from there, multiply and divide. But let's do multiply first because it's on the left. Then we'll get to the divide too on the right. All right, so that's why, yeah, so anyway, so let's start with do the brackets first. Is there anything in here that we can clean up? Okay, yes, so we can add the x's together, 4 x's, and then numbers together. So -2, there's more of those, so -1 wins, divide by 2. All right, and then from there, we got to multiply the 4x in. So this is where we might branch off into the 2 methods. Oops, let me get rid of this, or just move it down. Okay, so if you're using the FOIL method or the distributive property method, you're going to multiply that 4x in. Okay, you're going to multiply this here, multiply it there. Okay, so here we go. That's 16x squared minus 4x. Okay, multiply it to both of them. 4 times 4, 16, x times s, x squared. 4 times -1, -4, x times nothing, there it is. Okay, so then we did that, and then we're going to divide by 2. So I want you to keep in mind that this is all here, okay? So here's where maybe putting it underneath was better, okay? So you could write this like that, divided by 2. Okay, so when you write it like that, you can also show it this way. Both of them are divided by 2. Like that. So this is our way to cleaning up our final answer here. Oops, okay, so, all right, so then we'll go 16 divided by 2 is 8, x squared. 4 divided by 2 is 2, like that. Okay, and they're not like terms, but on top of it, you're being asked to subtract these terms. Yes, so don't put them together. Okay, yeah, so here's the other method. Okay, so you are taking this expression here, and again, I'm just going to write it over 2 right now. I want you to take the top and use the area model on it. Okay, so over here, we're going to put the 4x here, 4x minus 1 here, 16x squared minus 4x, pop them out. Okay, there we go. All right, but then we got to divide by 2. So I'll just write it back in the equation here. All right, so yeah, divided by 2. So same thing as before. You can write them both over 2 like that. All right, and then we got the same answer. So there is the area expression. I know it's not a nice final number, but it's an expression to represent the trapezoid expression for this specific trapezoid here. Okay, all right, so please, again, like I said, go and do lots of questions so you can get really good with those essential multiplication of positive and negative numbers, and then collecting the like terms and cleaning up the question. Okay, so you're expanding and you're simplifying. The expanding part is the multiplying, FOIL or the area model. The simplify part is the collecting the like terms, so don't change the letters, okay? But when you're expanding, when you're multiplying, yes, you can change the letters, right? X times x is x squared, okay? 4 times x is 4x, and so forth, okay? All right, so just work on those check your understanding questions next.